So, hello everyone. I am Eunice, and together with me is Francis. And today we will be solving problem 2C from our learning task 5.1 in our number theory module. And our task is to evaluate the expression 53 cube mod 9 using the properties of congruence. So, Francis will perform the computation, and I'll explain each step and the reasoning behind it so you can understand not just how we solve it, but why the method works. So, are you ready?
So given that 53 is equals to 8 mod 9, and that means 53 and 8 leaves the same remainder when it's divided by 9.
So, why is this step valid? So, this step uses the definition of congruence. So, it states that two integers a and b are congruent modulo m if m divides a and a minus b. Again, I will read it. Two integers a and b are congruent modulo m, if m divides quantity a minus b, or equivalently, a minus b is equal to km for some integer k. So in our case, 53 minus 8 is equal to 45. And since 45 divided by 9 is equal to 5, we know that 9 divides the difference. So 53 is congruent to 8 modulo 9 is valid. So this allows us to replace 53 with 8 in any expression as long as we're working modulo 9. Got it?
And using the congruence, we substitute, we will get 53 cube is equals to 8 cubes and mod 9. Now we can compute it, the 8 cube first. 8 cube is equals to 8 times 8 times 8. And 8 times 8, as we know, is 64. So it will become 64 times 8. And the final answer will be 512. That's for 8 cubes.
So why is this step correct? So this step uses theorem 3.2, specifically the power property. If A is congruent to B mod M, then A raised to the power of K is congruent to the B raised to the power of K mod M for any positive integer K. So since 53 is congruent to 8 mod 9, raising both sides to the power of 3 gives 53 cubed congruent to 8 cubed mod 9. So this is a valid transformation because congruence is preserved under exponentiation.
And now we can reduce 512 modulo 9. Firstly, we can have 9 times 56, which is equals to 504. And 512 minus 504, which is 8. Therefore, we can say that 512 is equals to 9 times 56 plus 8. So therefore, we can say 512 is equals to 8 mod 9, because the remainder here is 8, and here we have 9.
So why does this step works? So this step finds the remainder when 512 is divided by 9. So we use the division algorithm. A is equal to Q times M plus R, where R is the remainder. So here, 512 is equal to 9 times 56 plus 8. So 512 is the A, 9 is the Q, 56 is the M, and 8 is our R, or our remainder. So therefore, we conclude that 53 cubed is congruent to 8 mod 9.
And our final answer is 53 cubes is equals to 8 mod 9.
And to close, so this problem shows us how congruence properties helps us simplify large expressions. So instead of calculating 53 cubed directly, which is a huge number, right? We used substitution and modular reduction to make the problem manageable. So we applied the definition of congruence, the property from theorem 3.2, and the division algorithm to find the remainder. So every step was justified by a rule from our module. So that would be all. Thanks for watching our part of the video, and we hope that this helped clarify how to use congruence rules to evaluate powers of modular number. Thank you, and see you in our next video.